So hi, today I'm going to discuss the next question in the Leetcode top interview 150 study plan, that is candy. So what this question basically asks us is, suppose there are n children standing in a line. Each child is assigned a rating value given in the integer array ratings, such that for example ratings array is 1, 0, 2. So each child must have at least one candy, and there are only two conditions that each child must have at least one candy, and children with a higher rating get more candy than their neighbor. So that if rating of mm, one here is greater, so there must be if this child has one candy, this must have at least two candy that is greater than his neighbor because rating, his or her rating is greater than the rating of his neighbor. Another example here is 1 2 2. So here 2 are equal, so they can have the same number of candies, that is 2 and this must have 1, that is 1 lesser than 1. You know, we have the first, second, and the third child with 1, 2, and 1. So um, they it is satisfying the condition, but there is no condition for key whether we have to keep the same number of candies for the people with the same number of candies. So if we are giving 1 to the first one, 2 to the second one, and 3 to the third to the third one. So the easiest approach for this question is basically we iterate again and again until all the conditions are satisfied, starting with one candy each child, but that would be a costly solution because we have to iterate again and again until the array is like saturated and all the conditions are during. Another solution which exists here is a greedy solution. So the approach basically here is there are only three types of situations when we are moving from left to right. That is the number of the rating for no, x and x plus 1 is same. We need to code for that. The rating of x plus 1 is actually greater than x, that is the this element is greater than this, or the rating decreases, that is a downhill slope. So we need to only code for these three situations. So let's first define int answer is equals to 1, so that um, like if we are starting from any index, the rating is at least 1 in that case. So now what we need to do is make the int I is equals to 0. That is we will start iterating from the 0th index while I is lesser than n. So let's name n, make integer n as the size of the array ratings, that is the number of children we have, and while I lesser than equal to n. So now when we are done with this, what we need to do is while I is lesser than then n, that is we have now reached the end, and current rating is actually equal to the last rating, um, that is ratings I minus 1. Oh, we could actually start from I is equals to 1. Okay, so we are going to start from I is equals to 1 so that this can check doesn't give us an error. And then what we need to do is answer plus plus and I plus plus, that we keep on moving forward and we need to do a continue, so that we move to the next iteration. For the second case, that is we could have a uphill slope or a downhill slope in case of the ratings. What we need to do is make two integer. First will be int peak. Let it be 1. Int down also equal to 1. Then we need to start iterating. First, we will check for the increasing slope. That is, if there's a case like 1, 2, 3, 4, that is, the rating keeps on increasing. So all of the neighbors, concurrent neighbors must have at least one candy more than the previous one so that it doesn't violate the condition in the continuous increasing sequence. So yeah, while I is equals less than 0, and we need to check whether current rating is actually greater than the last rating, that is I minus 1. If that is true, what we need to do is increase the peak by 1. That is, we are currently, we will add another element to the candies, that is answer plus equals to peak, such that it doesn't violate our rule and we keep on moving forward with this. And for the final step, we need to do I plus plus, that is move on to the next index. Similarly, we are going to do for the down. So why are we doing this for down also? Because for example, there is a slope. We have reached 4 that in the increasing slope, and now we need to go down. So what we will do is 4. There's a case 4, 3, 2, 1. That is, it is going down and down again and again. So we need to keep track of for those case also, but then in that case we don't always not need to keep it as same as the current, that is, we don't need to keep it 4 only. If there are only 3 elements, we could make it 4 2, like the current element is 4, so we could make it 4 2 1. Why that? Because there's not a strict condition like we have to name it according to the rating. Only that key, they should have at least one candy greater than uh, the 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 child which has a higher rating than them. So if it is, for example, 4, 3, 2, we could give it a rating as follows: 3, 2, 1. And while we are adding, what we are doing is basically we are adding 1 plus 2 plus 3. Because when doing simple math, if we start from 1, if we like iterate till for 3 iterations, or we uh, go down this, it is going to, it will give us actually the same sum, because 3 plus 2 plus 1 is actually equals to 1 plus 2 plus 3. So we could, for that, we could simply do ratings I ratings I minus 1, that is the rating of the previous child is actually greater than the current child. So now, not what we need to do is increase the down by 1. Answer plus equals to down, that is adding to the count of candies. And what we need, the last step is increasing the index by 1. So for the final step, there could be some case like uh, 1, 2, 3. Like we give initially for increasing of a slope, but when we reach the slope, it might not always mimic the same as rating. That, for example, the rating might actually be 1, 2, 10, but we are giving 1, 2, 3 because it also like satisfies our case. So for while going down, if there's a case like 10, 8, 7, 6, 5, let's say 5. So for this, we need to give ratings like we have given 3 for this. So we need to at least give a rating greater than that to, for it to be like satisfying our criteria key. If the rating of the neighbor is greater than that, we need to actually give more candies to that child. So to satisfy that, what I'm going to do is uh, add another if statement, that is if peak if down is greater than peak, that is the current down is greater than peak, what we need to do is answer plus equal to down minus peak. What does it? It caters for this difference, because like there are four elements, and there are three elements. So we need to add the one element difference to that, so that the peak doesn't get violated. That is, we would be adding 4 plus 3 plus 2 plus 1. But to for it to be valid, we need to add down minus peak, that is the difference between the um, down and the peak element, so that it actually still gives us the correct answer. So now when we are done, we could simply return the answer. Let's check if it is working fine. So it is giving compilation error. Ratings, done the spelling wrong. Ratings here also, okay. Ratings, okay. Let's see now, okay. It's giving a wrong solution. Okay, 102. So what am I doing actually wrong here? Let's see. Let's see if I do this. Will this work now? Um, so it is still not working. Let's do this. Hmm. Both are giving wrong. So one minus one. Okay, so it is giving correct now. Let's check for all the test cases. So yeah, it is working fine. So the time complexity basically of this solution is of n, because we are going through the array ratings only once, and doing operations on that only, constant operation like increasing the count of down or increasing the count of peak, or increasing the count the answer. For the space complexity, we are using constant variables only, and not any the things like maps or vectors. So it will be O of 1. Um, and as of for the algorithm, like I explained till the last, when this case like violates, first we are going to check for the same rating. That is, if there is thing like 2 2 2, we are going to add 1 1 1 for all these cases. And why are we going to add 1 1 1? Why shouldn't we add, like, it might be the case key it is greater than the neighbor, or lesser than the neighbors. So because herein we are lastly checking for down. So when we are lastly checking for down, if there are a new element comes up after that, that is actually currently equal to it, we can simply assign it 1. Because it is actually lesser than it, so no matter what, it could be assigned this 1, because it satisfy the criteria of ratings. And as like the ratings of each of these are same, we could simply similarly assign each of them 1. Then we will be checking for the greater element, then for the lesser, again and again, until we have reached the end of the array, that is n. So yeah, that's it. Thank you.